in physics, electricity. Okay, actually we have a shortage of time, so what I'll do is I'll try to introduce about all this topic and I'll try to summarize it about in 5 to 7 minutes only. So it's very easy, guys. Suppose if I'll ask you what is electricity means, basic definition. If a kid will ask you what is electricity means, what you will tell? It is a form of energy. They can say that it is nothing but it is a type of energy. We can say that if we'll ask from a kid who is studying first time electricity means, what we can say that okay, it is what, it is a type of energy. But exactly what is the definition of electricity is, electricity is all about, it is a branch of physics. It is nothing but it is a branch of physics in which what we do, we study about the charges. Okay, what we do, it is a branch of physics in which we study about charges. Okay, charges. So, see, automatic, if I am going to ask you, if anyone is going to ask you about exactly at that time itself, if I tell you about electricity means, in your mind it should get tackled about that electricity is nothing but, if we are talking about electricity means we are talking about charges. Okay, so basically what it is a branch of physics in which we study about charges. Means charges, we know that charges are two types, positive and negative. We'll come about that, but first of all we will complete it. So basically electricity is nothing but study of charges. Okay, now second thing, if I'll ask you the types of electricity, then there are two types of electricity. Okay, electricity is divided into two types. First one we call it as static electricity. Okay, and second one is current electricity. So guys, I'll tell you very simple. See, like types of electricity is two types, static and current. So basically static electricity, if I'll ask you static, the term static means only which are in rest form. Okay, so what we have to study in static electricity, we have to study about the charges which are in rest form. Okay, static electricity is nothing but static electricity is study of charges in rest form. Okay, in rest form means the charge should not move, the charge should not be in motion. That type of electricity where the charges are not in motion, they are in rest form. So that type of electricity is known as static electricity. Static means rest, and electricity means, already I told you that electricity is nothing but we are talking about charges. Anywhere if electricity words come means, automatically it should tackle in your mind that okay, electricity is nothing but study of charges. Okay, but it's so, if what is static electricity, it is the branch of physics in which we study about the charges which are in rest form. Okay, see, basically what you have to study in 10th standard note here, we have to deal with current electricity, and this static electricity we will come to know about it in 12th standard. Basically these type of static electricity, they will be coming in electrostatics. Okay, like what we call it, the charges which are in rest form, we call it as electrostatics. Okay, electrostatics means whatever we are going to deal with in static electricity, we are going to deal with the charges which are in rest form. Okay, now electrostatics, that type of static electricity is only known as electrostatics. Okay, statics means in the rest form. For example, if I tell you about the static electricity means, suppose I will tell you very simple example so that you can correlate with that. Okay, so suppose this is a marker, right? Okay, and if I trying to rub it from any corner, suppose I am rubbing it. So after some time, what will happen? No, if we are going to put that marker where, or like this one I am rubbing, and if I am going to put it on a piece of paper, what it will do? No, it will attract that piece of paper. So basically, what happens? No, wherever you are rubbing, no, at that point itself, the charge is generated. So that charge is only, if you are going to put it on a paper means, that charge will get transferred from one body to another. That's why the paper will get attracted. This is a very perfect example for static electricity. Suppose anything, if you are rubbing over here, no, so what we are doing is we are generating a charge, and if you are going to put that marker only where in a piece of paper, what it will do, no, the charges which was there in the corner side, no, they will transfer in the paper, and automatically the charge, that what we call it, marker will attract the piece of paper. Why? Because suppose if we are rubbed from this side, so at this side, this end, we will develop a charge, and that charge, if you are going to put it on a piece of paper, what it will do, it will get attracted. So that type of example, that type of electricity is known as static electricity, and that we have to deal in electrostatics, which we will study this in further classes in a detailed manner, that is electrostatics in 12th standard. Okay, after about current electricity, just wait 1 minute. So second thing is current electricity. Okay, actually we are running out of time, guys, so basically I'll try to introduce about the chapter. At least you should get an idea what electricity is. So current electricity is nothing but, there is just a small difference over here. Current electricity is nothing but it is a branch of physics in which we study about the electricity. Means automatically you should hit in your mind that, guys, electricity is nothing but study of charges. So current electricity is nothing but it is the study of charges which are in motion, which should not be in rest form, it should be always in a motion. Okay, so basically it is nothing but the charges, study of charges, or anytime no need to write, charges which are in motion. Okay, that is called current electricity, and this current electricity only you have to study in 10th standard in very deep, guys. And in the coming 12th standard we will going to study about static electricity, means electrostatics. So what is the example for that? If we are talking about current, means current electricity means that we are talking about the charges which are in motion. Okay, now I'll tell you one thing. You know about insulator and conductor, right? Insulator is nothing but it is a bad conductor of electricity. Conductor, it is a good conductor of electricity. So always remember, guys, that this static energy, that static electricity, no, that static electricity, who is responsible for producing that static electricity? Nothing but insulator. Always remember, guys, insulator is responsible for insulator is responsible for static electricity. Now what about this current electricity? This current electricity is nothing but who is responsible for producing that motion, the charges which are in motion, who is responsible for that? So that thing is known as conductor. Okay, so always remember, guys, that we know about conductor, insulator, conductor, good conductor of electricity. So that will come under who is responsible for that current electricity? Conductor. And who is responsible for static electricity, means the charges which are in rest, is called it insulator. We know about conductor and insulator. Good conductor of heat is. So basically what we have to do over here, anything which is responsible for current electricity is known as conductor, anything responsible for static electricity is known as insulator. Okay, now if I tell you the example for that, it will be more clear for you. Okay, so first of all you should know about conductor and insulator. I hope that you are very much aware for that. Conductors is nothing but which allow the flow of current, and insulators are nothing which do not allow the flow of charge, or is any type of charges or current. Okay, so basically if I tell you about that insulator, means what I told you, static electricity is responsible for insulator. So what I have given the example, if you will rub it over here and a piece of paper will get attracted. So this is made up of what? This is what? A plastic, right? Anything which is made up of plastic, goods and all, that comes under insulator, means which are the bad conductor of electricity. And what about conductor here? Conductors are those materials which have good conductor of electricity. So example for that, good conductor of electricity is metal wire. We can say metal wire, or is electrolytic solution, acid based solution, anything. All these are what they are responsible for current electricity. Why? Because in this part the charges are in motion. And what about insulator? Like I have given you the example for plastic wood, no, if you rub it then the piece of paper will get attracted. So that is the best example for insulator. Okay, now coming to the point, that why conductor like metal wire, what I told you, that metal wire is a good conductor of electricity. But if I'll ask you why metal wire is a good conductor of electricity, means what you will tell? Metal wire is a good conductor of electricity. How and why? How we can say that it is a very good conductor of electricity? See, always remember, guys, if you have to know about the metal wire or anything which are good conductor of electricity, so any material can be good conductor of electricity if they have free charge carriers. I will repeat once again. Any material will have current electricity, or any material will have the good conductor of electricity if they have free charge carriers. Now what does it mean? Means free means which is like always free, no need to disturb it. Okay, so free charge carriers means anything which are in free form. Okay, free charge carriers means anything which are in free form, and we should not have to stable on that. Okay, we should not. Just telling you guys, what I am telling you is metal wire is a good conductor of electricity. How and why? Because they have free charge carriers. Free means carriers means movable, means wherever the charge should be in motion. Any charge which can be in motions are called as current electricity, and they, for that only they are responsible for a good conductor of electricity. Means if you have to know about good conductor of electricity, means any conductor can be good conductor of electricity if they have a free charge carriers. Okay, now if from this point guys, we will tell you that anyone can ask the question that every atom, what is atom? Atom is basically everything is made up of atom, so all atoms should be good conductor of electricity, but it is not like that. Okay, all atoms, it's not necessary that all atom will be good conductor of electricity. Those atoms will be good conductor of electricity which have at least one or two, or in quantize in multiples of that, they should have free charge carriers, means they should have movable charge, which the charges which should be in motion. Then only we can say that okay, that electricity is a good conductor of electricity, and that atom will conduct, which that atom will also conduct charges. But every atom is not like, every atom is not a good conductor of electricity, because every atom don't have free charge carriers. So the atom which have the free charge carriers will have what? If the atom which are have free charge carriers, means they will have a current. What I am telling is, so like any wire or any metallic wire or anything in the universe, like any atom is made, any atom is not like good conductor of electricity. Why? Because for getting good conductor of electricity we need free charge carriers. Okay, now coming to the point, like free charge carriers are only responsible for good conductor of electricity. Okay, we got it. Now if I just summarize you, actually we are running short of time guys, so I'll tell you about the difference between that, like in conductor and in insulator. We know that the difference between that, right? We know the difference between that, right? We know that current electricity is the study of charges which are in motion. Okay, now if I tell you that conductors are what? Conductors, no need to differentiate between conductors and insulator, we are already aware of that. Conductors, what I've given you the example for conductors, conductors are metallic wire, means metallic wire are good conductor of electricity. Okay, and if I'll ask you about insulator, means anything, plastic, wood, anything, you can say that it is a bad conductor of electricity. Okay, now if I'll tell you about the difference between metal and non-metal, what you're going to say guys, basically it's very simple, then only you will get the concept of atom also. See what happened with metal and non-metal, no? Basically there is only one trick that you should know, automatically everything will be covered. So what is basically metal? Metals are those components, metal are those components which allow the flow of charge. Metals are those components which allow the flow of charge. Non-metals, like it works like an insulator, means it does not allow the flow of charge. And what is the main scenario for that? Always remember guys, that metals, the size of atom, no, the size of atom in metals are very large. The size of atom in metals are very large as compared to non-metal. The size of atom is very small. So this is only responsible for good conductor of electricity. What happens exactly? See, size of atom is very large, means what we can say, suppose this is a atom, okay, and this is the nucleus and proton will be there. So what will happen? They will be like revolving around it like this. No. So the more they have the bigger size, what will happen? The electrostatic force of attraction. See, anything, if the earth is also revolving around the sun, so why it is revolving? Due to that centripetal force which is acting on that. So anything, if you are telling about that, anything if you are telling about metals, if the size of the metal will be greater, no, then what will happen with here guys? The force of attraction, here what we have, like proton and neutron in the center, and electron will be revolving around it. So the force of attraction for that nucleus will get weaker as the size of atom will increase, no, the force of attraction will get weaker, and due to that only, what we get, due to that only we get free electrons, because this electron will be free, and that free electrons will be responsible for current electricity. Okay, now what I am going to explain is that free electrons how free electrons will come in metals? Because they have a very big size, that's why the free electron, the force of attraction will become low, and due to that force of attraction will become low, no, that electron, particular electron will be like free. They don't have any type of tension or anything, they will be like fully free. Okay, it will get more clear, guys. See, suppose this is a wire. Okay, this is a wire over here. So this upper part of the wire is made up of plastic, right? But what about the inner part? Inner part is like this, right? Like some metal wire is always inserted over here. So that metal wire is nothing but this is only what, that is only that metal wire is responsible for the flow of the electricity. Means metal wires are nothing but conductor, and the upper part of metal wire, the upper part of metal wire which is made up of plastic is insulator. Okay, insulator. So basically, what is responsible for the production of electricity? It is nothing but conductor. Okay, so that conductor, what they do, no, they will allow the flow of charge. How? Means suppose this is a current, no, so what they will do, they will allow the flow of charge. Suppose this is a wire. Okay, and here some charges are there, like electrons are freely moving. Okay, electrons are freely moving. So in metallic wire, what we will have, no, they will have free electrons. So free electrons means what will happen, they will have the motion, because anything which is in free form means they will have the motion, and that type of motion is random. Okay, that type of motion is random. And suppose same thing, the motion is in random when we are not providing anything. And suppose if I, what I will do over here, suppose this is a circuit. I hope that you know about circuit, guys. So this is a voltmeter. Okay, and what I have done over here, no, I have added a cell is nothing but a source of potential difference or the source of power. Okay, we will study that same thing in like the later topics. Okay, so what will happen, no, suppose if we added or if we put a cell over here in any metallic wire, this is what, this circuit is what, metallic wire. Okay, which is responsible for the flow of electrons. So if any metallic wire is connected with the cell, no, then what happens, no, they will have a proper systematic like proper systematic means proper pattern. So what will happen over here? They will have proper systematic motion. Okay, what they will have? They have a proper motion. Okay, when we will add a cell. So cell is nothing but it is a source, a power source. If we will add that cell, no, automatically that random electrons will start moving in a systematic manner, and they will have a particular direction. And that direction is nothing but the electrons move in from negative to positive direction. Okay, so the electrons move from negative direction to positive direction. Okay, and apart from that, one more thing is there, that electron moves from negative to positive, but the direction of electron, this is the direction of electron in a circuit. Okay, now, but if I tell you about current direction, then conventionally, I am using the word conventionally. Current conventional direction is from positive to negative. We take it from positive to negative because it was further invented before the discovery of electrons. So, and we know that no, anything which if you have to measure means if anything will go from high level to low level, right? Anything will go from high to low. Okay, high to low. So what does it mean? High to low means, or high pressure to low pressure. Air is will go from high pressure to low pressure, or any heat will transfer from hot body to cold body. So exactly the direction of electron is like negative to positive, but the direction of current is just opposite of that. Okay, now just we are running out of time, guys. So what I'm going to tell you, I'll just explain you that what we are going to study in that. Okay, so basically I have already got the introduction of electricity, which type of electricity will responsible for which type of conductor will responsible for which type of current, rest or motion current. We have already got it. Now what I'm going to explain you over here, one more simple topic is, like we are studying about physics means what we are studying in physics, anything if we are studying means we are studying about the physical quantities. Suppose in kinematics we study about the physical quantities as motion, Newton's law. In circular motion, gravitation, we study about the physical quantity. Similarly, in electricity also we have some physical quantity that we have to study. First one is nothing but charges. Okay, second one is nothing but potential difference. Okay, second one is nothing but potential difference. Okay, potential difference. Third one is current. After that, fourth one is after that current we have resistance, and last one we can say resistivity, and the last one topic is nothing but electric power. Okay, so these are the things you should study up in this up to 10th standard. This topic, these physical quantities, all are what, all, if we are studying about physics, no guys, so always remember that if we are studying about physics means we are studying about the physical quantity. So these are the basic physical quantity which we have to study in electricity. Okay, now, and some more topic is there like applications of electricity. In this one we study about Joule heating effect of current, Joule heating effect, or else application of heating effect of current, that we have to study. And like after that what we have to study, we have to study about electric power. So these are the things that you have to study, guys. Actually we are running short of time, so I hope that you have at least got the introduction clarity what basically electricity is. Nothing but study of charges, and there are two types, statics and static electricity and current electricity. Basically statics means the word itself means rest, so charges which are in rest form is called static, or is electrostatics, which we are going to deal in 12th standard. But we have to study, basically focus on current electricity which are in motion. Okay, so this type of motion means if any charges are in motion means who is responsible for producing electricity, that motion of charges, who is responsible in that, conductors. And who is responsible in static electricity, insulator, because I've already given the example for rubbing, no? And after that, what are the phenomena that we studied? Metallic wire or wire good conductor, because they have free charge carriers. Any atom, if they will have free charge carriers, means that atom will also be good conductor of electricity. Got it? Now, after that, what are the points and direction? Direction of electron is negative to positive, but conventional direction of current is positive to negative. And what we have to study about the physical quantity, these are the 6 basic physical quantities: charges, potential difference. This is also known as voltage, guys. Okay, voltage, current, resistance, resistivity, and electric power. These things we have to study in types of electricity, or in electricity. Slowly we are going to deal with all those topics, but we are running short of time. I hope that you have understood the introduction for electricity. Thank you.